Hello everyone, welcome back to Adrian's Digital Basement 2. We have a super mini mail call here. This package comes from, I think, Christian in Slovenia, and it actually was lost for a little while, but it obviously has been found. But the box, well, it's definitely a little crushed in transit, so hopefully whatever's in here is not damaged, and let's cut it open to take a look. Hello to all my viewers in Slovenia. I don't think I've ever gotten a super mini mail call or a mail call item from Slovenia before, so that's pretty cool. All right, what do we got here? Ooh, Commodore MPS 803. Is this like a ink cartridge or something? Oh yes, it's an ink cartridge. Or a ribbon, that is. Ink cartridge. What is this, an inkjet printer? No. So I wonder if this is in good shape. It doesn't look like it's ever been printed on. I'd say that this is brand new old stock. I'm not sure what this blue piece is. And it looks like here we have a printer. Let's see if this has survived. Well, yes. I think there's maybe one little tiny broken clip on here. And obviously the original ribbon that's in here, well, that sort of came out. Oh, okay, well, and the case itself is, well, shall we say, opened. Now, I can't really test this printer out because obviously this has got a two-prong 240 volt plug on here, but inside the box is an IEC cable. So of course, this is a printer for the VIC-20 or the Commodore 64 or C128, and it connected to the same port as the disk drives, which is the IEC port here. And you could chain a printer and a disk drive or two disk drives or probably two printers or whatever, a bunch of different components, modems and things, all into the same serial connections. There's basically two connectors on every device. Now, even though the case has popped up like this, there looks like there are clasps here and they're not broken. I think it just got jostled. So if I take the screws out of the bottom, I could probably reassemble this printer. And right here, Commodore MPS 803 printer, 240 volts, 200 milliamps, 50 hertz, made in Japan. All right, what else is in the box here? Let's keep going. Oh, looks like we have a part of the printer. All right, and I say this is a motherboard of some kind. And there's also a note in the box. We'll look at that in a second. And that is it. We have everything else unpacked. Just throw that over there. Take a look at the motherboard. All right, so Commodore 64 right off the bat. RF shield in quotes. That just came right off. So we have a Commodore 64, assembly number 25407, a very common design. In fact, my Zip64 is this exact motherboard. And these were made in large numbers. The 64 was extremely popular when this was being made. Now this one, while it seems to have a full complement of chips, it's got some socketed stuff there, but that doesn't necessarily mean it's been reworked. We can flip it over to see, and yeah, definitely that socket's been changed. Those have been changed. Looks like something's been done here. There's a bodge wire. That would be for this RAM chip right here. So some traces were ripped. So there's a good chance that this doesn't work. Let's see what else there is to say about this. That cap looks a little unusually different. So maybe someone swapped that at some point. But I am noticing one other problem with this, and I guess this happened potentially during shipping. There is a severe bend in the board here. Now, I don't think it's broken, actually. I think the shield here for the cartridge slot is what's creating this. Let me see if I can bend that back into shape. Oh, actually, before we do that, let's take a look at the note. Dear Adrian, I contacted you about my C64 motherboard a while back, and I do apologize it took so long to post, but sometimes life just throws you curveballs. Yeah, I can relate to that. As I said in my email, I found my old 64 in the attic and it won't power on. It will, however, blow the fuse every time you do try to power it, and that's why there's none included. Hopefully you can get it working or at least get some parts off of it for spares. I'm only including the motherboard as I will be reusing the case and keyboard to build myself a RetroPie machine out of it. I even found the Kira product, which will allow me to use the keyboard on the Pi via USB. It even powers the cased LED for bonus. Yeah, that's awesome. I really recommend that. If you find your old 64 and it doesn't work and you don't feel like going through all the effort to try to fix the board, especially one like this that's been, you know, worked on in the past, just put a Raspberry Pi inside, and the key rod mounts where the power connectors and the joysticks are and allow you to use the keyboard and all that stuff via USB to the RetroPie, or, you know, which is just a Raspberry Pi. That way you're getting rid of all the unreliability of these original boards, because look, I mean, to be honest, they're unreliable and the parts are getting harder and harder to find. So when you use a Pi with the C64 keyboard and case, you get the feel of using your old machine, but yet the reliability of a Raspberry Pi. Not to mention, you can also emulate a VIC-20 or a PAL or an NTSC 64, like, or anything, you know, any other retro computer as well. But the fact that you're not just using a Raspberry Pi with a standard modern keyboard, using the original C64 keyboard brings back a lot of the feelings of using the old machine. So I really do recommend it, and it's a great project to kind of relive it, but without having to deal with something like this. As a surprise, I've also included my old MPS 803 printer, which is 240 volts. It does power on, so it might still work, but I would bet that the ink tapes are probably dry after all this time. Hope you find some entertaining use for it. Thank you for your great content you make for your channels, and have a good one, Christian or Chris. Thank you very much, Chris. Very nice letter. Let's see if we can get this C64 working. So first things first, I need to try to fix this very bent corner here. Hopefully that's focusing. Take a look at that. It's all bent up in the corner there. I'm assuming that happened during shipping. Let's see if I can try to fix this. Well, I bent the shield back, and yet the PCB is just so bent. Not really too sure how to fix this bend. Maybe hot air? Should I like blast hot air at this side of the board and then just kind of bend it? I'm gonna give that a try. I have the heat gun here pointing up. I have the motherboard, and I've wrapped the ports in some aluminum foil here, and there's capped on tape as well, just to try to keep those from melting. Not really sure how effective that's gonna be, but I'll put this right here in the corner. So I'm just sort of bending it. You know what? I think that's actually helping. Let's do that again. Focus right on the corner that's bent. Yeah, that's doing the trick. So I know it's hard to see, but you can see that it's a lot less bent now than it was. This little corner is still quite bent, but I can try to bend that back with these needle nose here. Okay, now it seems like this whole section is still bent up a little bit, so I'm gonna do another cycle of the heat. Let's try to just bend this whole thing down a little bit. Yeah, this thing is actually looking quite good now. It's a little bent down in this corner, so I'm going to apply heat there now, like that, and I'll try to fix that one corner. I mean, this doesn't need to be perfect. Obviously, when it's in a case, if this gets reinstalled, it gets screwed down into it. We'll kind of straighten it out again. But it was so bent badly on this up that I think it would have made the port alignment very difficult. This is bent down. I need to try to bend this back up. Ouch. All right, the noisy heat gun has been unplugged and moved away after it did its cooling. So let's get these capped on tape off here. Let's see if any kind of burns happened. No. Ports and switches are all in good shape. Still a little bit bent. It's not perfect, but you know what? It's plenty good. All right, so this machine, as Chris said, it was shorting the fuse as soon as you powered it up. So let's start doing a quick investigation to try to figure out what's going on exactly. So the fuse on the 64 is specifically handling the 9-volt AC input that's coming in through the power connector. That AC input is bridge rectified. There's the bridge rectifier right here, which could well be shorted. That could be immediately blowing the fuse. But then it also goes through these caps here to generate, through these voltage regulators, the 5-volt and the 12-volt rail. So the 12-volt rail is for the SID and the VIC-2 chip. But I'm gonna imagine right off the bat that I bet you this bridge rectifier is probably shorted, and that's probably what's just blowing that fuse. Let's get the multimeter here. We'll do a very quick investigation. Okay, we're on diode check here. So that's working. So let's just quickly check the bridge rectifier. That's fine. I know you can't really see it, but we have no shorts across the bridge rectifier, yep. 0.53 is the diode drop, which is fine. 5.3, 5.3, and 5.3. Okay, so bridge rectifier, that is actually a good part. Let's check the 12 volt regulator here. I'll set this, okay, still on diode check. See if this is shorted. Nope. Nope. No, that's fine. That's fine. No, okay, no short on that regulator. Let's check this one here. Nope, we're good on this one as well. Okay, so the regulators are fine. The bridge rectifier is fine. Could this inductor be bad? Possibly, but I'm gonna remove the SID and the VIC chip. Let's get these out of here because you know, it's possible that one of these is shorted and that is killing this thing. So that's the SID chip, and there is the VIC2 chip out. So theoretically now, when we power this up and I put a fuse in there, I may just jump this, to be honest. I mean, what's the worst that's gonna happen? It will blow up the offending component. The two things that run on the 12 volt with those two chips there aren't even in the board. Don't ever jump the fuse if you want to preserve your equipment. I'm gonna do it right now for testing just so I don't keep blowing the fuses out. So I'm gonna get this set to voltage. Let's turn this on, see if anything smokes. No smoke. All right, let's check this. Okay, we're getting 11.9 volts on the 12 volt rail. And on the 5 volt rail, 4.98. So those are working. Let's turn this on and let's see if anything's getting hot here. Are these caps okay here? No, they're fine. I'm just gonna bend the various components that are bent over. In fact, I'm just power this off and I'm just gonna bend these because these little disc capacitors, sometimes when they're smashed down, it's possible the leads can touch. It doesn't usually happen, but it can. So sometimes it's good just to kind of double check that none of these are bent into weird ways. So. Incidentally, there's one other thing that does run off the 9 volts. So after it's converted to DC, it's sent as unregulated DC to the tape connector here. And there's a little Zener power supply thing here. I think it provides 6 volts or is it 9 volts DC for the motor inside the cassette drive, the data set. But all of the logic here, that's all 5 volt logic, that runs off the other part of the power supply here. The part on those original bricks, at least the ones in the US that are all potted inside, they can go bad and put more than 5 volts into the machine. 5, 6, 7, 8 volts. And when you get 7 or 8 volts on TTL logic, it starts to destroy chips and stuff like that. So unfortunately, it's a very common failure mode of 64s. They've had a power supply plugged into them that actually ended up damaging a lot of the components. But this thing, it seems like it's working. What I'm gonna do is I'm going to unplug this little clip lead here. I'm gonna use the multimeter in current mode. So let's move the probe over to amps here. And we're gonna measure across the fuse here, and we're just gonna see how much current is currently being drawn by the voltage regulation that's going on here. But right now, we're not gonna have any voltage on these two voltage regulators. Why are we getting this milliamps here? Let's clear this out, relative it out, okay. All right, 340 milliamps. That seems like quite a bit, actually. I'm actually not really sure what normal is on a 64. So what I'm gonna do is I'm gonna grab the Zip64, take this out, and I'm gonna pop the fuse out of that. And we're gonna take a look just to see what the Zip64 is, which is exactly the same type of board, right? As I mentioned, there it is. It just has the RF shield removed on it. Let's remove the VIC2 chip, and we'll remove the SID as well. So we'll be in the same exact configuration here, and I just need to get this fuse out of here. And then we'll put the probes on the fuse here, and we'll turn this on. Okay, so we're getting 253 milliamps, and wasn't the other one about 330? So an extra 100, which does seem a little high, but I don't really know if that's a problem. So if we turn this off, now notice with the fuse out, there's a power LED right here. When I turn this on, there's still a green light. So there's still voltage going to all the logic chips. but you're not getting the 12 volts DC to the VIC and the SID chip, which of course would cause the machine to not work properly. So I'm just going to reinstall the two chips here. And let's take a look how much current is drawn with those installed. All right, 712 milliamps. So that's what like a normal operating 64 is. And let's see, this fuse that was in there, which I have never changed, is 1.5 amps, 250 volts, so 1.5 amps. So there's plenty of headroom. And he said it was blowing the fuse every time he swapped it out. So we put this multimeter back on here and turn this on. Yeah, 339, 338. So it's getting about 70 more than the other one, even in this state right here, which is a little unusual. I wonder if there's a problem up here in this section of the board with the data set. All right, so I brought up the schematics here. I want to look at the pins on the VIC and the SID that use the 12 volts. So let's see if I can find that here. So there's VCC, that's 5 volts. VDD, that's going to be the 12 volts. So pin 13 on the VIC2 here. So this would go in like that. And pin 20, which is on this side, that pin right there, that's ground. So I'm going to take the multimeter, we're going to set it to ohms. Let's get out of the continuity mode. There we go. Let's hook up to pin 13, or sorry, pin 20 and pin 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so 1.8 mega ohm. So that's fine. That's not a problem right there. And then here is the SID chip right here. The SID, I mean, I'm suspecting that if any chip is going to be bad, it's going to be the SID. VDD 12 volts. That looks like it's pin 28. Of course, if we can actually just check on the socket right here, let me put it in pin 28 and turn on the power. No, we're not getting anything. Oh, there's no fuse. That's why. Let's hook the clip lead back up again. It's hard to read the schematics. I just want to verify that this is the 12 volt rail. Yes, there it is. Okay, we're getting 12 volts. And I'll double check on here. It's the pin 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, there's 13. Touch that to there, and we turn on the power. There it is, 11.9. Okay, so on here, let's see what's the ground pin. So we know 28 is 12 volts. Ground is 14, okay? Putting this on back to ohms. We're gonna go between ground, 28. Okay, 252 ohms. That may or may not be a problem. Let's grab the SID out of this machine here, which I know works. And we'll do exactly the same test here. 247 ohms, basically the same. So this is weird. I'm not seeing any kind of faults with this machine. Now, I'm reluctant to put my good chips in there, right? I don't want to potentially damage them. And I need to look to see if I have any spare fuses. I do not want to power this up with the VIC and the SID in it with that clip lead on there. Okay, here's a 1.5 amp right there. And let's see if I have more than one in case I blow it out. Another 1.5 amp, so I have 2 of those. Let's move that out of the way. All right, let's pop. Oh, that fuse just sort of sits in there very loosely. I have to bend those little contacts in. Let's see. Bendy, bendy. There we go, nice click, click. All right, let's power this up with this fuse in here without the chips in there and see what happens. Okay, good, it's not blown. Let's grab the multimeter again, just make sure we have our good old 12 volts that we're looking for. And we do 11.9 volts, so that's good. So that fuse is so far not blown. Let's go to the VIC2 chip, because of course that is necessary for this machine to work. All the pins are okay. Ooh, a couple bent. I'm just gonna get this white sticky stuff off of here, or not sticky stuff. Oops, I just put alcohol on my LCD screen. 99% IPA, shouldn't put that on LCD screens. That might have just actually damaged the plastic on the monitor. So I have this cleaning stuff here, screen cleaner. Let me try to give it a little clean where I just accidentally sprayed some 99% on it. Hopefully that didn't permanently do anything to the plastic. No, it looks like it's fine. Okay, let's get this clean here. So there it is, 6569R3. You know, I'm not familiar with that being the part number for the VIC. I am just not super familiar with the PAL version. Yep, there it is, PAL version 6569R3. Okay, we're fine. Okay, that is in there. Let's start by turning this on, and I'm gonna measure the 12 volts off the socket here to the VIC, or sorry, the SID. Let's see if it blows, the fuse. No, we are still working. Okay, with that said, why don't we plug this into the monitor or into my computer here, and let's see if we get a video output. I mean, I'm assuming this machine is non-functional. All right, so that should be the video input through the RetroTink. What I'm gonna do is unplug this. I'm gonna test it with the ZIF board first. I've really found you could save yourself a big headache if you double check that everything is working perfectly with a known good machine, if you have one, of course. That way I don't have to be concerned that maybe the problem is my video cable's not working or something else. See, I'm not getting a picture here. So something else is wrong right now. This should be the RetroTink, and yet I'm not getting that. Occasionally this happens, and this is because I'm set up through this whole capture system here, OBS, but more specifically, there's the Elgato capture device, and occasionally that has a problem, and it appears that that's the case. Let's see here. Yeah, no, it appears that the Elgato isn't even visible right now. What's happening here? So I'm gonna unplug it, plug it back in. This whole mess of wires here to see if I can get it working. Oh, what a hassle. Elgato Game Capture S. Okay, so at least it's showing up. Oh, I think we're working. There we go. See, I had to freaking unplug and plug it back in. That is why it is important to double check that all of your stuff is working, because I could have been going down a wild goose chase with that other board. Maybe it just works, but I wouldn't have known. I would have thought it was a black screen or whatever. Okay, confirmed functional, at least the cabling I have here. So let's go back to Chris's board here. Here it is. Plug this in. So as a side note, the video connector on Commodores is always right next to the RF modulator. So if the RF modulator were over here, like I think it might be on like the 128, the video connector is next to it. So just a little quick way to know which is the right one to plug it into. Obviously you can't plug this connector into the IEC connector, like they're not the same connector. But okay, here we go. All right, wait, look at that. OBS crashed. Okay, we're just gonna move that off to the side because we still have a video picture. It's freaking working. So Chris, what kind of madness is this that you were having so much trouble with it? I wonder if your power supply was the problem. Now what we haven't done is I haven't plugged the SID chip in yet, but the computer fired right up, you know, with the new fuse in there. I wonder if you had a fuse that was maybe undersized. I don't know. Okay, well, I'm gonna plug the SID in. So let's get this in here. And let's see if that blows the fuse. Because maybe the SID is bad. It's quite possible. They fail a lot. Here we go. Okay, hasn't blown the fuse. It seems to be working. So Chris, the only thing I'm thinking is that maybe this board had an undersized fuse and whatever you kept replacing it with was undersized. Maybe your power supply was faulty. Like it's just 9 volts AC that comes into this. Maybe there was too much voltage and the regulator was having a problem with it. I don't know, I can't say. But I'm gonna plug a cartridge in here. Let's just put a little Deoxit in the connector. Okay, I like to just sort of try to wipe out any dust that might be in there. It's just it's a bit grimy, that's just normal. All right, I have the double-ended diagnostic, so dead test or the regular diagnostic. We'll plug in the regular diagnostic here. Here it is. Weird, I don't know what that was all about, but it's obviously running. Now I don't have the test harness connected, so we won't know for sure if everything was working, but this appears to be a working 64, which didn't need anything except a new fuse and just some bending back of the board. Chris, if you're watching, please comment below. Let me know what size fuse you had installed or you kept reinstalling on this board. Because the 1.5 amp here is fine. Do we have sound? Where's my cabling for the sound? It's not plugged in. My speakers aren't plugged in. Let me get those connected up. Okay, I have the speakers hooked up, but instead of letting that loop through again, let's get this out of there and we'll switch over to Easy Flash. And I think everyone knows what that means. Oh, Easy Flash is not working. Okay, so this computer actually does have a fault. Let's see if it's still, loading into normal. Yeah, okay, so that's working. I'm gonna suspect that this problem right here with Easy Flash is the PLA chip. Working, but not really that well. So I'm gonna yank out the PLA and we'll swap it out with another one. All right, well, this is kind of weird. I don't have a PLA handy. I usually have a couple sitting over here, so I'm gonna borrow the one out of this machine. This is a Russian PLA chip, or Soviet Union era. It's basically a clone of the original Signetics 82S100, and it's a Soviet clone from the 90s. And using something like a Data I/O, which I have, you can actually program these to be completely compatible. I gotta bend the pins here, because I have never used it anything but the ZIF socket on that other machine. Here it is. I was looking for the lead former bender thingy. Let's do that. But yeah, you can make a chip that's completely compatible 100% with the PLA chip. Only thing that's a bit different is the lead spacing is slightly different, but it still goes in without any issue. Okay, there we go. Let's see if this machine works now. There it is. Like I said, faulty PLA chip can be mostly working and then not quite, which is why this cartridge didn't work. Easy Flash does a lot of trickery with the 64. I'm looking for my keyboard, here it is. It does a lot of trickery so it can do the swaps of kernels and stuff in real time. So we'll plug in the keyboard here. Okay, there we go. So like if we do Jaffe DOS, so that's actually swapping out the kernel that's soldered into the motherboard. Normally not possible. And that's all possible because this cartridge is, like I said, a lot of trickery on the motherboard, but you need a really properly working PLA chip for that to happen. And clearly this one here is faulty, but that wouldn't have caused the problem that Chris was having with the shorting of the fuse or the blowing of the fuse. Okay, Adrian's tools, 8-bit dance party. Let's see if this SID works. May not. It's working. And it's PAL, so it's slower than maybe some people are used to hearing, but this is the way that this song was intended to be heard at the right speed. All right, so I'm obviously very used to the way the SID should sound, and that sounds absolutely perfect. No issues whatsoever. So this thing appears to work. Let's just put back in the original PLA just as a control, just to make sure that maybe it wasn't just like a bad connection in the socket. So out with my Russian one here. By the way, I didn't say about the Russian ones, you really do need a programmer that's compatible with programming the 82S100, the original. Well, actually, no. I think actually you need a programmer that's compatible with programming this device as well, which the Data I/O 2900, which I have, is, but there are not a lot of things left that can actually program those. This chip has been desoldered from something else, this PLA. So I don't know if it came out of this board or it came from another machine. Are we gonna have a working machine? Nope, black screen. So I bet you without this cartridge it works, but it's not gonna work with that. There it is, it's working, yep. So marginally faulty. Not totally faulty, but marginally faulty. So I'm gonna draw an X on that because for me, marginally faulty is not good enough to actually work. I'm just gonna put an X and I'm gonna draw a P on it for partially dead. So yes, there we go. Thank you very much, Chris, for sending in your old 64 board. I just don't understand why you couldn't get it working. And for me, it just basically worked, except for this. I'd love to know about the history of this machine. Like, why were these ICs replaced? On the back here, we can see that, what is that? That's the CPU has been changed out, and whoever did it didn't even reinstall a socket underneath. So that's been changed out. This RAM chip has been changed out. These ICs here have been reworked, and you can see they're in sockets. But the PLA was always in the socket, so that was not done. So if this PLA came out of a different 64, it must have been at some point someone did a replacement. So I'd like to know how that happened. And there is a bodge on this RAM chip right there, a very thin little bodge wire, but obviously it works. So whoever did that rework did a decent job. And I just needed to put a new fuse in, and a new PLA, of course, and this machine fully works. So sweet. Thanks, Chris, for sending this in all the way from Slovenia. I'm glad this package was found because, like I said, it was lost for a while. Not by me, but it was lost in shipping. But it did make it to me eventually. And there it is, a working PAL board, and that's it. Thanks to my patrons. Names are scrolling on the side of the screen. If you want to become a patron, you can do so at the link in the description below. That flashing, by the way, is totally normal. It's not even connected right now. It does that. That's the RetroTink. I usually keep it turned off just so it doesn't do that because it's a bit silly. Hit subscribe if you haven't already. I really appreciate it. It helps me out a lot to subscribe. I don't know why it's still flashing. That must not be the RetroTink. And I can't even exit out of this full screen because OBS has crashed. Oh no, OBS, okay, there it's gone. It quit. And that's it. So look, really, thumbs up if you liked it. Thanks for watching. I'll see you next time. No, wait, stay healthy. I'm a mess today. Stay healthy, stay safe. And I will see you next time. Bye.